So I want to take just a couple of minutes and try to introduce you to the concept of big data, and I'm going to try and do that through a metaphor you already know, which is a soup can. If you got a can of soup and you spin it around, you can sort of read what's on the inside of it, right? But let's say for whatever reason you lose that label. So then what's in the can? Something as simple as, are there any carrots in the can? You really don't have a way of knowing. And the reason I use the can is because this is what you see anytime a geek is drawing a database schema or whatever. They use a can for your database. And the only way to actually find out if there's anything in the can is you have to use a structured query language, some sort of something like this that says, select from can where content equals carrots. And if you throw that together, if there are any carrots, and if you throw that together with some other line statements, you get some sort of cute little graph, right, that illustrates something. But what if there aren't any carrots? Or broccoli, or beans, or cheese? What if this is chicken noodle? I mean, you don't really know. So it winds up becoming sort of this giant game of Go Fish for those of you that have played the card game. So where this really comes into play is if you're some sort of a user administrator or somebody, you're trying to ask them, you say, I don't even know what to ask for. Isn't there just a way to sort of look at what's in the can? And a geek will say, well, sure, here's all these SQL tools, use those. We say, no. Something normal, and as people say, well, just show me the data, or give me the data and I'll find it myself. What they're really talking about is sort of this. They're familiar with your basic spreadsheet, and a database is essentially just a multi-tab spreadsheet to them, which is not a bad metaphor to be thinking, but it's not quite accurate because what they forget is just something as simple as those two columns of numbers aren't really columns of numbers to the database because everything's in binary. And really there actually aren't any columns, and really there actually aren't any columns or rows, and so essentially if I were to hand it to you, what you really get is this. And even if you happen to think of that in sort of this multi-dimensional tab sheet, all of your data is rarely in the same tables and columns and forms, or it's just this giant strange mess, right? And so trying to find relationships is what big data is really about. And the number just gets completely goofy if you go, even a simple 10-column spreadsheet, it multiplies exponentially, and it multiplies in binary. So even just one row with 10 columns, the possible relationships between any of those points look something like this, which is just, too big for normal people to get their hands around. Fortunately, brighter minds than ours have thought this through. I'd like to highlight one, Fernanda Viegas, double PhD out of Brazil, who's been romping the gold with the globe with a friend of hers the last few years, trying to get people to understand with their project called Hint FM. It's not hint.com, it's Hint FM. But they have kind of this interesting approach that big data, yeah, you got a lot of data points, but that really isn't what makes it frustrating. What makes it frustrating is people can't get their heads around it after relatively short amount of data. So they say, look, what really makes it big data is trying to find a way to display it that it means something to somebody. So I'd like to just illustrate that with a couple of things. This is one. I'm actually going to tell you this website, and it's going to look a little goofy here, but basically the internet is this giant museum, right? You can find these great works of art, but it turns out the internet lies to you. And so there we go. So when you go and you look up some of these famous paintings, as it turns out, it depends on who scanned it as to what size they scanned it, and the tones they used and everything. So they invented this piece of software that basically, here's an example, famous The Birth of Venus. We're going to analyze just this little piece right down here, and there's 32 different possible versions of this. What if you accidentally got this yellow one? I mean, you could totally hate this work of art and not even know that you got a crappy scan, right? So they tried to find a way to display this and show, of all the versions out on the internet, this is what you might run into. And here's that heavily yellowed tone one. But they're not even the same for the edges and what size they were scanned. And so basically this is just a tool where they tried to graphically display, hey, you may not even know that you're getting different data here. They've got another one here. It's called the wind map. Let's see if I can move this and make it a little better. So, all the schools and universities have these little weather stations, and they have these digital readouts that say the wind is currently blowing out of the northeast at 10 miles an hour or whatever. Well, this was their attempt to sort of stitch that all together and take a look at what the weather looks like at any given time, real time. And you can go back to some pretty famous days in history. And I just love some of these because this is real-time data as it was streaming on that day. But you don't need some 5 o'clock weatherman to draw some line and tell you where the hot and low air masses are converging. You can see it. The data is displaying that in front of you. Now, you couldn't query this, but the data, they found a way to display the data in a manner that it makes sense. So I want to go back to the presentation, and whether you're looking at that or that, they actually have a global one now that you can take a look at. Here's another one. Some of you remember the Barkside. It was a Super Bowl commercial that went viral a few years back, and the company that actually, quote, quote, made it go viral made a lot of money on this. But Fernanda, working with Google, said, hey, we really want to track this sucker down. And so they found a way to actually track who shared what with who. And this was the Volkswagen marketing companies, who they shared it with. And of course it went viral, so they got paid a lot of money. But if you look, actually, these are all the people that shared it with everybody that made it go viral. And if you missed it, right there is actually the marketing company's influence. I don't know who Chris is, but he should have made a lot of money. These are just different ways to analyze the data. And you're starting to say, well, okay, maybe I got it. But just stick with me. I got one more example, I think, that might seal the deal. There's another guy named Ben Schmidt who was plotting from the captain's logs the latitude and longitude of where the ship was for some ships, and he could track their paths. And then as he thought about it, he says, well, that's kind of cool, but I really didn't know where this is going, but I wanted to play with it. He decided to carry this through. So he actually went through 5 decades, and you can barely see anything here, from 1750 to 60 to 70 to 80 to 90, up to 1800. And you start to see some patterns, right? And that's the key to understanding big data, is that in order to understand big data, all you really need to realize is that what you're seeing are the holes in the data set. Those outlines of the continents that you recognize are actually holes in the data set. What you're seeing are all the places that you cannot drive a ship. And for the life of you, what your mind sees is actually not in the data. That's the whole point of this, okay? Big data has very little to do with the size, and it has everything to do with how you're going to display the data to show what's not there. You can't write an SQL statement and get this, okay? Because the pattern is not there. It's not in the database. So that brings up the big question of this whole thing. So when you're talking about big data, the question you need to have is what's missing? What's missing from our data set? What is not in your database that you're going to be asked to display somehow in the future?